All right, I'll introduce our next speaker. Some people call him the Norse god of thunder, Thor. Most people might be the actual speaker himself. So please give a hand to Filip Ekberg. He's going to give some talk about mobile web.
Thank you very much. So I'll be talking about Azure Mobile Services, and specifically how we can use the .NET Backends for Azure Mobile Services, which was pretty recently introduced by Microsoft. Before that, though, I want to thank all the sponsors. I know everyone here is thanking the sponsors in all their talks, but I really want to thank them again and say that this is really awesome. Without them, we wouldn't be able to be here. So thank them, download their products, buy their stuff, show your appreciations. I'm Filip Ekberg. I'm a C# MVP. I wrote a book called C# Smorgasbord, which I hope everyone will buy after this talk. I work at Redify as a senior consultant, and if you have any questions during this talk, please do feel free to interrupt me or ping me on Twitter afterwards. So the agenda for this talk is going to be going through a quick recap of Azure Mobile Services for those of you that might have no idea at all what that is. And then we'll take a look at the .NET Backends and see how that changes the way we want to use Azure Mobile Services. We'll talk about offline data and why it's important to bring data offline to cater for different types of clients. And we'll also talk about alternative data stores such as MongoDB, SQL Server, and so forth. So has anyone in here looked at mobile services before? Quite a few of you. Cool. And how many of you really like Azure Mobile Services as it is? Like working with the NodeJS backend? No hands. All right, cool. So I hope this is going to help you towards really liking mobile services and what they have to offer out of the box. So Azure Mobile Services is a way for us to provide a scalable and reliable backend in the cloud. It lets us run this backend in Azure, which provides us with this scalability and reliability. I do know that Azure went down a few weeks ago, and that was really not the best thing to have in a talk, right? So it should be quite reliable. And it's backed by Node.js. Now, the Node.js backend has kind of frightened some people. Specifically me, I do like working in C#, and I'll talk about why the Node.js backend has its ups and downs. One of the best things about this is that they're providing us with a dynamic data schema. So think of defining an API. You just set up your classes in your C# files, and then Azure Mobile Services generates what the table of data will look like. If you change your model, it'll update that table, which is pretty awesome. Most likely something you want to turn off when you go to prod, but during development, it's pretty good. They also provide us with a cross-platform experience. So think of all our data being inside the Azure, and we have these endpoints that we can connect to, and we have clients for all these different platforms, such as iOS, Android, .NET, and they also give us a REST API on top of that. So this means that we can cater for all our mobile devices and all our mobile clients. They also provide us with push notifications. Think of if we get data pushed into our API, and then we want to notify certain users about that, we can send push notifications to Windows Store applications, Windows Phone applications, Android applications, and iOS applications. They also gave us the capabilities to create authentication and authorization. Think of logging in with a Microsoft account, an Active Directory account. Think of on-premises AD connected to Azure AD. We can log in with Twitter and Facebook and Google. That means that if I have a mobile application, I have the backend written in Azure Mobile Services, I can set up my mobile application to authorize with Twitter or authenticate with Twitter, and then I'm authorized inside my application to do certain things based on my usual level. So that's a pretty cool toolbox to get, especially when you're defining a backend for your mobile applications. Although it's built by Node.js. What you can do in your C# classes is that you build everything up, you connect to an Azure Mobile Service, and everything is just generated for you. But if you want to dig deep into this and change what happens when you insert a record of data, let's say that you're inserting a new news item and you want to hook the user that did that onto that record, you'd have to go into Node.js and change what happens when you insert or update your data. The problem with this is when you want to start debugging. Debugging Node.js means that we do console logging. We have to go into the Node.js backend and do console log debugging, and I really don't like that. So I want to introduce you to the .NET backends for mobile services, and this really changes the way that we're going to interact with the Azure Mobile Services. The way that it does that is by providing us with a powerful backend using WebAPI. Have anyone in here used WebAPI? Quite a few of you. It's a really nice way for us to provide an API over REST. What we can do is that if we already have a web API defined, we can take that and host that inside Azure Mobile Services. Together with the extension of the web API controllers, we also have the capabilities of using something specific for Azure Mobile Services, which makes it possible for us to talk to these clients that already know how to talk to our backends. And we can host this anywhere. So since this is web API, we could just as well take this code, put it on our on-premises cloud, or the cloud that we run in our cellar. We could put this anywhere. I don't see a reason why we wouldn't use Azure, since it's most of the time up. I can't say it's always up now, right? Because it does go down, but it's really a good and reliable option. And what's really important here is that they're still giving us this cross-platform experience. Even though we're using .NET and we're using WebAPI to define our backend, we can still use and consume this over the clients that we've done before. And what I really didn't like about the NodeJS backend is that it's pretty hard for us to debug that. Now, .NET is pretty cool to debug and develop inside Visual Studio. It's pretty easy. We can start things locally. We can publish this to Azure, and we can hook up a debugger to the instance running in Azure. So we get this really first-class experience when designing and developing our APIs. So I'd like to show you how I can do that. I want to set up a new web API locally that is taking advantage of the mobile services features. I want to show you how you can connect with a mobile service client to that, just as we've done with the previous backends before. So I'll be heading over to Visual Studio. And the first thing you'll see here is I have a prepared solution. I'm going to be somewhat of a chef today. I'm going to just show you a lot of things coming out of my oven. So here we have a project, which is a web API project. I have a to-do item controller here, and the idea is that I want to expose a certain type of data over the wire. Now what I want to do here is that the first thing that I need to define is what a to-do item is. So I can go ahead and go over to a folder here called Data Objects, where I have a to-do item class. I'm going to bring in this item here, and you'll immediately see that it inherits from something called entity data. Entity data defines a few different fields which Azure Mobile Services knows about. If we step into this here, you'll see that we get things like an ID, and we get version, we get when it's created and updated, and if it's deleted. If you work with the Node.js backend, these fields are very familiar, since they're the same ones that we would have in the Node.js backend. So now I've defined my to-do item. I've added 2 extra fields here, one for text and one for if the to-do item is completed or not. I know that the to-do item example is used in every mobile service example, but it's a pretty good one. Now the next thing I want to do is to define the controller. So this is basically going to be a web API controller, but it's going to inherit from something called a table controller. So we take a look at the top here. You'll see here that this is defining a table controller for a to-do item. And if we step into this a few times, you'll see here that it in fact inherits from a normal API controller. So it means that we can perform the normal REST operations. Now, the next thing we see here inside the initialize method is that we're setting up a few things. I'm setting up a data context which points to where the data for my backend is going to be stored. I'm going to store this in a SQL database. It's going to be a file-based database when this is running inside my local environment. And when this is pushed to Azure, Azure will inject where it's going to store the data. So it's going to tell me that it's storing this in SQL Azure instead. And the next line here sets up something called a domain manager. Now, when we're invoking our API and adding data or retrieving data, we need a way for our mobile service to understand how to retrieve and how to add that data. So we have something called a domain manager. And this is an abstract thing, so we could, in this case, define an entity domain manager. Later on, we'll see how we can define custom domain managers to interact with different type of data models or databases. And if I step into this context here, you'll see that this is in fact, a DB context using Entity Framework. All right, so let's run this here locally and see what we get. You'll see here if I set a breakpoint in the get all to-do items method and run this locally, hopefully all works well. it'll spin up, and we can see here that we can debug this and run this locally, just as you would with any WebAPI project. If it's been a while since you worked with WebAPI, then we introduced a very nice landing page for all our API controllers. So we can get something here saying, hey, this mobile service is up and running. And if I click try out here, we'll see a few nice additions to working with this and to developing this locally. We'll see a list of all the entry points and all the controllers that we have locally. So I could use a UI to go into this here and invoke my web API. But I know a shortcut. I can write table/to-do items, and we'll see here that we're hitting the breakpoint inside my mobile service, which is in fact running locally. And once this is processed, it's going to go ahead and fetch all the data from my local database. We can see here that we in fact get a lot of data returned back from this mobile service. Now this isn't really awesome. We're just getting some JSON spit out here from our normal web API controller. But when we go over to the client, we'll see that we are using the same kind of concepts that we've been doing before. So let me show you here. I've defined a client here. I'm using a shared project, a universal application, to define a Windows Store and a Windows Phone application. And inside the shared portable class library, I'm defining everything that I want inside my application. So this application will simply pull down all the to-do items. It'll let me add to-do items and mark them as completed, which a to-do item application would normally do. I've, of course, defined the to-do item as well inside the UI, so I know what I'm going to get back from the API. Now, if we take a look here at the back end, the first thing we'll have to look at is in the app file. We'll see here that we have a reference, or we have an instantiation of the mobile service client. Now, in this case, the mobile service client is pointing to our local version, but I could just as well uncomment this one up here and point to a live mobile service in Azure. And from the client's perspective, it doesn't really matter if it's .NET or if it's NodeJS, since everything that is coming over the wire is JSON, and this client here knows how to talk to the Azure Mobile Service. So if I just run this here and show you that it in fact works, I'll set the Windows application as a starter project. I'll start this. It will build this and deploy this locally. It will show us a very nice Windows 8 application. And it's not started, since I started kill the debugger. Let me start the backend again. It's a good way to show that it actually hits my local version. So now that that's up and running, let's run this application again. Hopefully that works better. So now we've got all these items here. And I want to show you that this is in fact storing everything locally. So we have this folder here called app data. And if I expand all the files, we'll see that we have this MDF file in here where it's storing all this data for this mobile service. So we get this here on the side here as a data connection. I can browse through the tables. We have the to-do item table. I can select all the data. And it will show me the same things that we saw in the browser and the same things that we saw inside our application. Now I've developed this locally. I have this working and running. Now I want to publish this to Azure. So a simple way to do that is to simply use web deploy. I can right-click on my web API project and tell this to deploy to Azure. And I have everything set up here. I have the publishing profile that I've loaded. I've connected to my Azure account. It pulls down the publishing profile with all the passwords and all that. So I can just click publish here. But as a pro chef, I've already done that. So what I want to do now is that I want to hook up a debugger. So I can right-click here in the Server Explorer and see all my mobile services. And I can click Attach Debugger. Now when I do that, it will go into the Azure instance of IIS. It'll hook up the debugger to that and let me debug my application while it's running in Azure. And let's see if this works. It should. Copy the URL. Just add /to-do items. And now it's prompting me for a username and password. The easiest way to find that is to head over to the code again. Remember the part that I had commented out? There's a key here that you can find inside the Azure portal. And if we copy this key and paste it into the password and leave a blank username, we'll be able to hit the service. I hope it's the right key. And now it's telling us here that we have hit the breakpoint that I set inside my application. So this proves that we can hit Azure, as this here points to Azure, and I promise I haven't set this up in my local hosts file, so it's not pointing locally. All right. So in summary, we saw that it's pretty easy for us to define a new local web API like we've done before. We can publish this easily to Azure, and if there's a problem, we can hook up a debugger to the instance running in Azure. This makes the development easier, and it makes it much easier for us to find problems. So the next thing that I do want to talk about is going offline. One of the things that I find is that people tend not to think about offline as a primary experience in an application. A lot of applications today requires us to be online all the time, like Internet of Things, right? We want everything connected. I want to get a tweet from my fridge when there's out of milk and all that. But we need to think about developer or users that want data offline. So I do want to tell you a story of when I first moved to Australia. Me and my wife, we were looking for a good, reliable, and fast internet carrier, especially for, you already laughed, I haven't even said a joke, for our mobile phones. That's even more a joke, right? So we wanted to find a good, reliable carrier for that. We did realize that there's no such thing in Australia, right? So we went for the second best thing. We went for the one giving us the most data for the buck. The problem with that is that if you don't have any coverage, you can't use the data, which is their selling point. They want to sell you a lot of data which you can't use. We didn't really think about this since we live in Sydney. We weren't affected by that, but we had plans to go on a road trip up to Cairns and drive down to Gold Coast. Now we did this together with my wife's parents, which is a pretty good achievement alone. We spent 10 days in a car with them. We're all friends. No one killed anyone. Anyways, we were all social media addicts. One of the things that we really wanted to do was upload pictures to Facebook, telling all our friends about all the cool kangaroos and crocodiles we saw. Everyone loves their friends uploading pictures from their vacations. The problems are that we can't do that because there's no coverage. So this experience had me thinking, how can we cater for this type of usage without interrupting the user's experience in the application? Can we provide an experience that is better than that? Facebook, for instance, just tells us, nope, sorry, you can't upload the picture. You need to try again. It uploads half the picture, then just stops. Imagine that being a 400 meg video that you took of something, and you upload that, and at 399 megs, it tells you, sorry, you have to try later, and now all your data is out. It's not the best experience. So we do have different connectivity patterns that we need to think about. We have people that are always connected using a high-speed internet connection, which is no one in Australia. We have always connected people with mobile internet connection. These people use their devices differently. We have people that are occasionally connected. This might be people working remotely, people that only connect when they get home or have an unstable internet connection. And then we have people working in the mines or working from an airplane that are never connected at all. These people use their devices differently, and we need to cater for that. So the way that we could possibly do that is to think outside of the box. There's a company from Sweden called Spotify, which I think you all have heard about. They're by definition a streaming company and allows us to stream music to our devices. But they're thinking outside of the box and thinking, how can we solve this problem for our users? How can we let them listen to music even if they're offline? So they allow us to bring all the music down, and when we're on Wi-Fi, they make sure that the playlists are up to date. So we need to think outside of the box when we're designing our applications. However, we also need to think about that in Australia especially, it costs a lot of money to deliver data. Getting a 4 gigabyte plan for a mobile phone is really expensive. Getting more than that is really, really expensive here. Outside of Australia, it's pretty common to have unlimited data, which is pretty good. So why am I talking about all this when it comes to Azure Mobile Services? The reason for that is because they help us solve this problem. They give us tools to allow us to create offline support inside our applications. And the way they do that, we'll take a look at that in a demo later on, but they really provide us with a good tool set to provide a good experience for all types of usages. One of the reasons that we can store data offline is that they give out-of-the-box support for SQLite. SQLite is a self-contained, serverless, configuration-less, and transactional database, which essentially means that it's a file-based database. We point somewhere to the disk, and it simply loads that up and does its thing. It stores all the data there. And the good thing about SQLite is that it's supported on iOS, Android, Windows, Windows Phone, and almost any device out there, which is the same devices that Azure Mobile Service support. So wouldn't it be great if we could just tell a mobile service that when we are asking for a lot of data, just store it in SQLite and do that? That would be great. But we also need to think about when we want to synchronize data. Just taking data offline and storing it locally doesn't really solve a problem. We need a good way of synchronizing data, and we need to come up with a good pattern for when to synchronize data and when not to. Think about the different connectivity patterns. The people that are always connected, they don't want to be bothered by when to sync the data and when not to sync the data. They just want that to seamlessly happen in the backend. But the people that are barely connected at all, they might want to be in charge of when the data is synced and not. Because we don't want to use up their data. If they know that they're driving through Queensland, through the wilderness, they don't want to be bothered by getting a question, do you want to sync now? Do you want to sync now? We just want them to do that. How many of you in here have rolled your own offline support for any type of device? There's a few of you. Yeah, it's quite common to do that, and it has its problem, especially when it comes to handling concurrency. Concurrency issues are really fun because they're really hard to solve in a good way. Basically, it means that we need a good way to handle collisions. So go back to this trip that I was taking with my family. One thing that happened during this trip was that I got a text message from my boss. We all know that text messages is the best way to get a message through because the service is almost always up, even though it's an unreliable service. So I got a text message. My boss is telling me, hey, there's a problem. You need to update a document. This needs to be done ASAP. I didn't think too much about it. I started updating the document. I saved it, and my machine is set up to automatically upload that to the cloud, and I thought all was good. We were driving through Cairns, trying to avoid all the crocodiles, and suddenly my phone beeps and tells me there's a concurrency problem. Someone else updated the document before you, and now I can't sync your data. Because a few hours went by, and I didn't think about my data didn't sync until I got a good stable connection. Now, we all know that when you get a text message from our boss, they send that to everyone in your team. And the first one to solve the problem gets the best Christmas gift. I hope I got it, but we'll see about that. So I had two problems. I have data that is out of date. I don't know if it's the best one on the server. So I needed a good way to solve this concurrency problem. So who wins in such a collision? We have this group of people working with data offline. And then we have another group of people working with the same data offline. These are two independent offices working on the same type of data, but they have kind of cheap internet connection, so they want to save some money. They both want to update their data at the end of the day, but then there's a collision. How do you weight in who wins? We could just randomly select one of them, like take every second. That would be a fun way to do it. But we do have some concurrency strategies that we could follow. We could be optimists. Being a pessimist would mean that we pre-lock the data. Does anyone remember the day where you worked with source control and you had to check out files and not let anyone else work with the files because you didn't want to have merge issues? Love it. Now, I like to be an optimist, so I don't want to have any locks. I rather merge the data when there's a problem. So I want to be notified of a conflict. If we look at how developers work with this problem, for instance, when we're using Git, we work with our code, we push that, and if there's a problem, we can be notified about there's a merge conflict or there's a conflict on the server, and then we can fix that locally and then push it again. That would be a nice way to do it. Although, in a client application, you would probably want to have an easier option. We don't want to ask our users to rebase. So can we ask the users which version to take? Although asking a user, do you want to take the local version or do you want to take the server version? Everyone chooses the local version. We all know it. So we could default to just one button. Okay. We could also do advanced conflict resolution, but it makes it a lot harder. We could do merging of data. We're not going to take a look at how we could solve this, but you could think about if we have a user record, for instance, and someone is changing the name and another person is changing the address, there's really no reason for us to decide of one version. We could just merge them. So let's see how we can take the data offline. What I want to do is that I want to bring in support for SQLite inside the client. I don't want to touch the server. I just want to do this using Azure Mobile Services and do this locally. So let's head over to Visual Studio and have the same type of solution here. But what I'm going to do now is that I'm going to change this here. Can everyone see the text, or do I need to increase the font size? It's good? Perfect. So this file here is the main page for my application. It's my universal application, and what I'm doing in here is that I'm simply saying that we have this mobile service table. And then we have a collection of items, which is just an observable collection that we can update and remove items from. But this one here is the interesting one. We have the mobile service table. This indicates that we are pulling down data from Azure Mobile Services. We're going into the app file where we saw before, where it's finding the service. This is pointing to a local version. I'm saying get the table for to-do item. That lets us understand what kind of data we are pulling from the server. In order for us to introduce offline support in here, I need to change this slightly to make it work with offline support. So I'm going to tell this to sync all the data when it's pulling it down from Azure Mobile Service. The way to do that is to simply change this to an Azure Mobile Sync table and to say that we're getting a sync table. We're done. Almost. Well, no, it's not as easy as that. The second thing that I had in my application is on Navigator 2, I'm just refreshing my UI. Now I do need to do a few more things. I need to make sure that the context for all this is set up. I need to make sure that we've introduced the SQLite database. So I'm going to get rid of this here. And I'm going to, oops, that's the wrong one. Let me get up here again. I'm going to change this here to do a few things. The first thing on the top here asks, is the synchronization context initialized? If we've already set up the synchronization context, we don't need to do it again. If we haven't, we're going to define a new local database, which is using SQLite. I'm going to name this something else because I'm pretty sure this will collide, give me a concurrency problem with the other databases that I've had. So, then I'm defining the table. I'm saying here that we are defining a table for the to-do item inside SQLite. And then I'm simply calling a method down here to initialize the synchronization context. Notice the second parameter here, that is the sync handler. The sync handler can let us work with concurrency problems, for instance. It can let us change what happens when Azure Mobile Service finds a problem. Now the next thing that I need to change here is what happens when we are pulling down data. So all that we've done up until now is to say, can you retrieve all the data from the Azure Mobile Service? And I'll show you how I've done that. Simply in here in the refresh to-do items method, I'm saying use the to-do item and just fetch all the items. However, this is going to go to our local version that we have now, which we haven't populated. So I need to do that first. And inside my UI on the bottom, I've introduced a button to refresh. It'll go after the service, it'll pull down all the data, and when we're trying to pull out the data using the table again, it'll find all that data. So I'll show you what that looks like. I have two methods in here. The first thing is that when I click this button, it's going to call this sync data click. And we'll see here that we have three things happening. First, we're pushing data. And notice how that's different from when I want to pull data. It's because they work a bit differently. When I want to pull down data, I can simply say, I want the data for this table. And then I can just refresh the UI, which this method is simply doing. But when we're pushing data, what happens is that it's going to call the app.mobileservice.syncContext.pushAsync. The reason that it's doing that is because it's going to look up all the synchronization context inside the application and make sure that all of them are pushed at once, in case there would be any concurrency issues. So you don't want to be selective when you're pushing data, but when you're pulling down data, you can be selective. All right. So let me just start off the backend, which is running on a different port. And then I'll set the Windows project as a startup one. And we'll start that off. there should be no data in here, which is good. If I right-click here and do a refresh on the bottom here, let's see if you can see that. Just click refresh down here. It'll pull down all the data. Now, interestingly enough here, if I change something, this item here, for instance, let's do that. I'll save that. And let's head over to the database that we have inside our backend and see if it actually stored this locally and didn't push it. So I'm double-clicking the database again here. We can see that it's the correct one. I'm going to go over to the, if I can find the mouse pointer. And check the, I think my trackpad died. Show table data. Hopefully, there's no extra exclamation marks on how are we today. So what I need to do is that I need to go back into the application and sync the data. And if I do that, if I right-click here again and refresh the data, it'll go off and push this into our database. It'll pull down the data after that and refresh our UI. So now if I go ahead and refresh this here, we'll see that we have a few extra exclamation marks. I do, however, want to get rid of that. But while I'm getting rid of this, the user of the application is also marking this as done. So if I go ahead and edit this and say that this is completed, and then I refresh the data again, can someone guess what's going to happen? It's going to blow up, hopefully. Do you know why it didn't blow up? Because the local version doesn't have any idea of what version number it is. What it's going to do is that it's just going to overwrite whatever you have on the server. It's going to say, I don't care which version it is, just overwrite it. And the way that you solve that is by introducing the version number on the client side as well. So the API is exposing when it's created, what the ID is, what the version number is, but we're not consuming that in the client. So we could go ahead to our to-do item here and simply introduce the version. And we set the version attribute there so that we know that this is a mobile service version. Now if I recompile this here and start off the client again and do the same kind of change. Let's see here. Let's save that. And then go ahead and go to the server. Sorry. Change something in here as well. Let's refresh this first so we know that we have the latest one. Set this to false. And now, hopefully, this will blow up. Right. It's not redeployed. So I found that sometimes when you're building and deploying Windows applications, it doesn't uninstall the previous one, so you'll have to force it to deploy a new version. So let's rerun this. Let's add something in here and make sure that it's different from what we have in the client. So this has completed. Now, hopefully this will work. Third time's a charm. And there it goes. Blows up. Tells us there's a problem. Now, this doesn't give us anything. It doesn't really help the user at all. We know that there's an exception. We couldn't sync the data. Thank you so much for that. So now let's go back into the code and fix that problem. And the way that we're doing that is by introducing something called a sync handler. The sync handler is in charge of what happens when there's a synchronization problem. So let me bring in the sync handler that I've already built, and we'll have a look at what this is doing. First off, at the top here, you see here that it implements an interface called iMobile Service Sync Handler, which indicates that we can do something when the execution of a table operation happens. We are trying to execute the operation. If there's a precondition fail exception, that means that it couldn't sync the data. We do know that there's a mismatch between what the server has and what the local version has. So we can go ahead and pull down the local version. We can take the remote version, and then we can tell the user, here are the two options. You have the local version, you have the remote version. Which one do you want to take? So this is simply creating a message dialog. We're giving it 3 buttons, one for taking the local version, one for taking the server version, and one for simply getting out of there because you can't decide. Now, it's interesting to note here what happens when we are selecting the server version. the version number we have locally, in order for us to trick the server that we are working on the same version, is to take the version number that we have on the server. So if I want to overwrite the server version, I'm just going to say, hey, we have the same version number, we update the same data, mine's the new one. So we simply do that like this. I'm saying here that the item that we're trying to update, the version of that is going to be the same version as the remote value. And then we are simply doing the operation. So now, if we use this sync handler inside our application, it should give us a dialog telling us that you can't sync the data. So I need to go ahead into the main page here and change that. We have this mobile service sync handler at the bottom here. I'm simply going to use the one that I created. So if we compile this and redeploy this application, we should in fact be prompted with a dialog telling us that we cannot sync the data, or you need to choose how to sync the data. This decides to deploy. There we go. We still have the synchronization problem. The data has been stored in SQLite. So even though we redeployed a new application to the client, we still have the same data because they're pointing to the same database. So I'm refreshing the data here. It'll tell me there's a conflict. How do you want to proceed? As I said before, we should just have one button in here. It should be OK. We should take the local version. So if we head over here again and just have a look at what's in the database. Sorry, my trackpad's really. Can I take this mouse? No, thanks. All right. There we go. Server Explorer. Show all table data, and it should hopefully be different from what we saw before. So if I refresh that, we see that it got rid of the exclamation mark, so it used the local version. All right, so that's pretty cool. We saw that we can take the data that we have in our API, even though it's running in Azure, or it's running on our local API that we're currently building, we can take that data offline and cater for different patterns. Now this synchronization where I got up the bottom bar, clicked refresh, we could automate that. We could check for Wi-Fi connection, we could check for a high-speed internet connection, and we could check whether or not the user would actually manually want to do this. So we have a few good options. Now the final thing I want to talk about is the alternative data stores. Now imagine the scenario where you have on-premises solutions, you have a lot of time spent on building these types of applications. You want to be able to take your current application and expose parts of that over mobile services because you want to take advantage of the push notifications and authentication and authorization. So we can use our on-premises solution, be it SQL Server, or if you have a MongoDB. If you have a SQL Server, for instance, with a very complex schema, you could do a mapping between what you're exposing over the WebAPI and what you are storing inside your SQL Server. And we have a wide range of support for different data stores. We can use Table Store, we can use SQL Server, MongoDB, and so forth. So let's take a look at how we can do that. I want to still use offline data, but I also want to use SQL Server and MongoDB. So the first demo, I want to show you how I can change the backend to use a completely different type of database, which is a document database. And then in a later example, I want to show you how we can use a complex schema inside SQL Server and connect to that using our mobile service. So if my mouse will start working again, otherwise we'll have a problem. I'm not a ninja when it comes to shortcuts. So I have the same type of application here. What I'll do here is that I'm going to change the backend. And then I do need to change a few things in the front end because working with document data is a bit different from working with SQL Server or entity data. Oh, come on. There's like one place on my trackpad that I can touch, otherwise it changes. Seriously? Does anyone have a mouse? That would be very helpful. Just gonna run up and get it. Thanks a lot. Cheers. Sorry about that. This is why you shouldn't buy custom-built laptops. Just buy a Mac. There we go. Perfect. So we have the same type of application here. We have the backend. We have the client. What I need to change in here is the way that we are invoking our API. So what we have here is that we have this domain manager that I talked about before. And the domain manager is in charge of how we are working with the data. So ideally what we want to change here is that we simply want to say, work with MongoDB instead and point me to the database for MongoDB. And that is exactly what we are going to do. We are going to change this domain manager. I'm going to get rid of these two lines because I'm not going to connect to the local database anymore. Instead, I'm going to use a Mongo domain manager, which is shipped by Microsoft. It's coming out of the box. We can use the Mongo domain manager just the same way that we use the entity domain manager. It tells us that we are expecting to have this MongoDB connection string. It's connecting to this table, database, and this table. Now, we also need to define this connection string to say where it's located. I'll go ahead and do that in the web config. Everyone just look away. Don't steal my MongoDB data. So that's it for the backend. Although, as I mentioned before, actually that's not it for the backend. When I initially did this talk at TechIt, I still used entity data as what I inherited from in here for the data objects. But this should actually be document data, since we are, in fact, returning document data. And if we go into that, it'll give us sort of the same things, but storing document data as an entity data, there's kind of a mismatch in what the ID is, for instance. So for document data, the ID is a string. We're generating a 24-digit hexadecimal number, which is a bit different from a GUID. All right. So now that we have the backend all fixed, let's just start that up and see if we can get some data out of it. I'm simply going to call /table/to-do item. And hopefully this will give us a different type of data from what we saw before. Remember, this is hitting the MongoDB that I have in the cloud, so it might be a bit slow. But as you see here, the ID is a bit different from a GUID. And to prove to you that this is coming from MongoDB, I am using MongoLabs. And you can see here, I have the collection here. We have 3 documents. And we had 3 documents returned from the API. We can see here that we, in fact, have the same type of IDs. I think your mouse died. Ha! It's probably is. I'll change the board. Let's see if I can do this without using a mouse. That'll be interesting. So I need to go to the client. Now, how do we do this? There we go. And I need to change the main page. The reason I need to do that is because when I'm updating and adding a new item, what I need to do is that I need to generate the ID a bit differently. So I need to do that on the bottom here. Does it work again? Oh, come on. Small steps. I need to generate the ID for Mongo. The way we do that is by generating a 24-digit hexadecimal number. And the only place where I want to use this is when we're creating our to-do item on the client side. Remember that we're storing data offline. Now the offline store is going to use a string for the ID, but it doesn't really know what to put in there. So we need to tell it how these IDs generated, otherwise it will default to a GUID. And that's not really going to help us when we want to sync this with the server. So I'm going to say that the ID is whatever we are generating. Now let's compile that. Oh, sorry. And now you see another problem here, which is good. SQLite doesn't work with any CPU. You have to be specific about which CPU you're targeting. There's a few gotchas when it comes to SQLite. If you want to target Windows Phone or Windows Store, you have to install additions to Visual Studio. Otherwise, you can't deploy the precompiled binaries. And you also have to change all the projects that you're running to be a specific target. You can't use any CPU. So I'll do x64 here. I'm going to go up at the top here to make sure that we are pointing to a correct database. Just going to change this here to something else to make sure it's unique enough. Let's rebuild this and redeploy. All right, so now that I start this, hopefully we'll see that we have different types of items inside our application. So let's refresh this. Right. Because it's probably not started. Let's start the web project first. Let's make sure it's the right ports. Yep. Now let's hope this works again. So many demo fails. I thought you were only allowed to do 3 of them. Let's try this again. There's something wrong with my local version. So let's skip that for now and see if it just magically solves itself while I talk about the next issue or the next problem that we want to solve, which is taking data from a pre-existing on-premises solution and bringing that over our mobile service. So let me just try to figure out how this mic works. Where this mouse works. Right. Actually, I do know what the problem is. There's a bug. Sorry? Sorry? Ha! Very funny. Not. The problem is there's a bug in Azure Mobile Services that doesn't let us invoke with all the OData operations. So by default, they will try to do top and they'll try to do skip on the items when it's selecting from the API. So I have a fix for that here, which will simply tell it to not support any of those table operations. So we can say here that we are not supporting any of them. If this doesn't work, it's probably the operator. Let's redeploy that. But if it works, you owe me a beer. Boom. Look at that. Yay. All right. So this is coming from Mongo, which is pretty awesome. All right. So in the next demo, we are going to connect to a local version of SQL Server. So I have a SQL Server instance running here. We'll see if we can get up to the top here. This is giving us a customer. It's giving us devices. Devices connected to a customer. And we don't want to expose this very complex data structure over the wire over our mobile service. However, we already have written a web API for this. At least in my scenario, the company built this web API. We're very proud of it. We're exposing something using XML. Let me navigate to the right solution. So in this case here, where is it? Come on, there we go. I'll just minimize this. So here we can see that we have this application, we have the customer, and what I want to do instead is that I want to expose a customer DTO. I simply want to expose the first name and the last name. I don't care about the relations to the devices, so my mobile service will be in charge of just doing that. Now, I'll first off show you what this API is doing today. It's built on WebAPI. We have an API controller that is simply returning everything that we have inside our customer database, which is awesome. It works for our current devices, but now we want to port this to mobile, and we don't want to send all this data over to all our devices. Imagine having 12,000 customers and all of them getting bloated XML. It's better to get JSON and just fewer fields. So what I want to do is that instead of exposing this over normal web API, I want to do mobile services. And what we can do to do that is that we can introduce a new table controller for that. So in this case here, I'm going to set up a table controller for a customer DTO. I'm simply going to expose the first name and the last name. Now, what we need to do here is that we, of course, need to use the domain manager. I need to say here, sorry, I need a way for us to connect to this using the domain manager. So we need to first create that domain manager because we don't really know what kind of data structure we have in the backend. So previously we've used the Entity Framework domain manager and we used the Mongo domain manager. But in this case, I need to use my custom one. So I have this custom domain manager here. I'm going to bring that in and I'm going to show you a few things in here. Basically, it's telling us that it's setting up a domain manager that is mapping between a customer DTO and a customer, which means that we have this customer complex object, which is then going to be mapped to our customer DTO. And then we're overriding or defining all these methods that we need to create our own domain manager, which is when querying data, looking up data, deleting and updating data. Inside our controllers, though, we need a way to use this. And just as you saw before, we introduced the domain managers inside the controllers. So I'm going to go over here and take that in here. So now you'll see here I'm setting up a data context to point to my local instance of SQL Server. It's not the file-based one that we saw before. And here I'm setting up the customer domain manager and pointing to that context. Now my customer domain manager knows how to fetch data from the database. And if you noted, you'll see here that it's doing a few different things, which is pretty weird. First, we're saying query to list as queryable. So a few gotchas in the API. If you don't do that, it'll blow up. Secondly, at the bottom here, we're doing update async, and we're parsing that to a GUID. But we know that the string is a GUID, and we know that when we're passing this into the database, it's going to look like a GUID. But this needs the strong type to know that it's correct. Otherwise, it'll also blow up. So a few things like that to keep in mind. Now, I'm going to run this and show you how it fails. It'll blow up and tell us that I have no idea what you're talking about. How do I change a customer to a customer DTO? And the reason for that is that I haven't defined how to map between these. I need to define a mapping using AutoMapper. And the way that we do that is by heading over to app start. I'm going to pull in a AutoMapper configuration. And this will basically tell us, hey, this is how you map from a customer to a customer DTO. We know that the ID is going to be the same as the ID, but we need to do toString. And then we also need to specify the other way around. Because in one scenario, data is coming out of the database, and in one scenario, we're adding data to our database. So let's run the client. Let's first run that again and make sure that it works. It should return data that we have in the SQL database. It should say Bill Gates and a few other names. Yep, sure enough it did. So now we can run the client. I'm going to set this as a default project. I'll rebuild that and redeploy. Need to change this so it's not any CPU. Rebuild and redeploy. So it's deploying this. We'll start this off. There's no data in the application. I'm going to refresh this. It's going to pull down the data from SQL database. So if I change this here, for instance, you'll still see that I could change this and it'll be updated in the SQL database. If I go ahead over to SQL database, SQL Server, select all customers, you should all now be surprised when we do not see Bill Gates. Do you know why? Because we need to refresh the data. Stored locally. I refresh that, it'll update the database, and we should see Bill Gates at the bottom here. It's perfect. So, in summary, we saw that it's very easy for us to, if you have a good mouse, to introduce offline support when still having MongoDB and having SQL Server. We can bring our on-premises solutions into the mix when working with mobile services. So in summary, all we've seen here is that Azure Mobile Services got a whole lot better. This is a much better approach than working with the Node.js backend. It's more flexible, but the Node.js backend might be work for you very well if you need to get up fast and need to just focus on the client and focus on the API. And we can create really powerful backends using WebAPI. We can use things that we already love about WebAPI. Imagine just smacking things like the authorize attribute that has people required to log in using Twitter or Facebook. It's pretty powerful. And we can easily debug this once it's published to the cloud. And the offline data lets us cater for all the different usage patterns. We can cater for the people that work in the mines and people that run from crocodiles. We can cater for everyone. And we have a good support for a wide range of data. We have SQL Server, Table Store, MongoDB, and lots of others. And if there's one that you find that you want to use that there's no support for, you can just create your own domain manager. And synchronization problems and collisions are fun to handle, and mobile service makes it easier for us, especially since we get these sync handlers, and out of the box, they let us do a lot of things and let us understand what the problem is. Questions?
The sync handler able to remove that collision?
Yep. So your question is, will the sync handler let us look at fields? Yeah, so you're pulling down the objects from the remote values and the local values. So you know the data types, you can check the fields. Yeah. That's how I would merge the data, for instance. Other questions?
Why did you generate the string random rather than fully parsed string?
For Mongo? Because Mongo doesn't use GUID. So your question was why I did the method to generate the GUID?
Yeah, I mean, why don't you use GUID?
I think I did. Yeah. Yeah, oh, right. Okay, so your question is why didn't you use GUID to string for Mongo? Because Mongo uses 24 digits hexadecimals. GUID is a bit longer.
How do you manage security and filtering? So if I'm a customer and I log on, I only want to synchronize the data for that particular customer.
So how do you manage security?
Yeah, so I'm a customer and I'm using my app, I'm using mobile services, and I want to see all my orders. I want to just synchronize all the orders down in one hit. How do I manage that customer or that user connecting, saying I'm authenticated as this particular user, now I'm going to send down the data that's relevant to me?
So your question is how do you filter data for a specific client that is requesting data?
Yep.
So in WebAPI, it's very easy to do that. You get the current user principal and you filter based on that. You can do the exact same thing using the WebAPI backend for Azure Mobile Services. So you can do anything in Azure Mobile Services in the .NET backends that you can do in WebAPI.
When you do the sync at one thing, are you deleted everyone else's data or not?
It shouldn't. That's a good test. I hope not. Well, your question was if you do a sync and there's changes, it won't delete everyone else's things?
Well,
Or?
there's 100 records and you only own 10 of them and you bring down to 10 and you sync it back up. Does it go, deleted the other 9?
No, okay, so you were asking if I have 10 records locally for my user, and when I sync them back to the server, how does it know if it's the correct records? You're sending the versions, and in mobile services, you only do soft deletes. Yep. More questions? Yep.
Does the concurrency checking just handle the black tables, or does it handle the lighting tables or like nested objects?
So your question is if it handles complex scenarios and complex relations. Ideally, you don't have any complex scenarios in mobile services. You just have flat structures. So if you have two related objects, that's really two mobile services or two endpoints. Think of it as microservices, very micro. More questions? If you have any more questions, yep?
You sync it in premise. Is it that we're going through Azure?
No, that's a very good question. So your question is if you sync to an on-premises solution or to your local instance, it does not go through Azure. So you can host this anywhere you like. It's going to go where you're pointing to. It's not going to go through Azure. Yep?
For the other platforms, for Android and for iOS, do you have a similar API available that you can use?
So your question is if you are using this in iOS and Android, do you have a similar API? Yep, you do. It's a very similar one. If you're using Xamarin, You use the .NET version, which looks very similar to this. If you're using native, they have native APIs that look very similar to this as well, but in the native look and feel. All right. If you have any more questions, please do feel free to ping me on Twitter or send me an email. Thank you so much for listening to me, and sorry about the mouse problems. If you buy my book, I can buy a new laptop.